Workshop Session 2. Last week, we talked about the Ampere method and briefly worked on two questions. I think that was true sum and palindrome number. Now we're going to be a bit more specific. Um, and before I start that, let me record this meeting. Yeah. Um,
I've started that.
okay. There. I'm just going to introduce myself. I'm Tal Ibrahim Traore, your technical lead for the 2023-2024 season under Google Developers Group. And today we're going to be talking about the technical interview prep workshops, session 2. Last week we talked about the Ampere method and worked on two questions. Now we're going to dive into more specific areas, and this is in relation to data structures and algorithms because these are crucial for technical interviews. Regardless of where you may want to intern, if you're going for like a SWE role, that's software engineering, you may need to be equipped with these skills. So, as usual, don't forget to RSVP. If you haven't done so, you could just drop your name in the chat as well as your email. Then somebody's gonna take note of that. Um, okay, I will share my experience as an intern at Meta a little later. But just for now, because I have a lot to cover within a short time, I want to give time the uh, for Zidwe and Sunday to actually work through the questions with individuals. But yeah, getting to know these skills could get you into places like Facebook, Microsoft, Google, you name it. So yeah, you're not limited at all. So we're going to talk about linked lists today and what they are. We're gonna first go into the theory, then you're gonna go into breakout rooms and solve a question in each breakout room using the Ampere method. So, but before we start, we get our questions from LeetCode, which is a popular platform. I won't spend too much time talking about it, but if you can, you can take a screenshot or just go scan the QR code and it should take you to the platform. And I would advise creating an account now because you will need it. Now, what is a linked list? Just as the name suggests, a linked list is a data structure where elements are stored in nodes, and each node basically points to the next one, forming like a chain. So linked lists are, let's say, values or uh, I'm just going to go ahead and say nodes or items that are connected to each other through pointers, forming like a chain structure. So the key concept that you may need to know here is that they're connected at all levels except the beginning and the end. That is, the first node has nothing connected to it behind, and the last one doesn't connect to anything per se. Yes. So unlike arrays, linked lists don't require contiguous memory and they allow dynamic memory allocation. So this is a bit more technical and you can read more in the QR code there. But basically, when we're using lists or arrays in Python, you need to have like one memory allocation that's completely like free. Like if we had, let's say we had a like a shoe rack, because I'm looking at my shoe rack. For us to be able to like use an array, the top, like we needed to have like an entirely completely free shoe rack. But for linked lists, anywhere there's a free space, we could like put in a value or a node. But the key thing is it's sort of the nodes are or the shoes are sort of connected to each other using the pointers. So this basically is what they mean when they say dynamic memory allocation, because the values themselves can be all over the place within our storage system, but they're all connected to each other using pointers, and that way we can access them. And yeah, just in case you wanted to know what a data structure is from, and you missed it last time, it's just an organized way to store, manage, or retrieve data efficiently. When you think of strings, lists, dictionaries, sets, for those taking the CS 104 class or have taken or know a little bit about Python, you may have used a list. So a list is a data structure. And the types of linked lists that we have are, I think we have more, but the major ones are these three. So we have a singly linked lists where each node points to the next node. And I'm going to explain more these in depth in the next slides. Then we have a doubly linked lists, which in which the nodes point to both the next and the previous node. Then the last type are circular linked lists, where the last node points to the first node. And yeah, so this is just a visual representation of how the singly linked list look. If you look at the image to your left, we have, I'm going to refer to these blue shapes as nodes from now on. So the nodes A, B, C, and D are where we store our values. Think of them as containers for the values. And if you look at the arrows, they all point to, well, A points to B, B points to C, C points to D. D points to what is known as now, and this basically means it's not pointing to anything. And this is important because we know this is how we identify whether or not we're at the end of this linked list. And the first node is usually referred to as the head or the root, depending on where you're like looking at your question from or what you're using. Then the last one is usually the tail. You won't always see the tail being indicated, but it's good to note. Then the pointers accessed using something known as next, which is created in a class, but that's a bit high level. And this is all you need to know. This is all you need to know to like understand how singly linked lists work. So yeah, this is the simplest type, and they basically store the data or the value and have the uh, pointer property. And in this case, because the pointer goes from A to B, you cannot go back to A from B. So you can only go one way. In this case, which is from left to right. If you were at B, there's no way you could go back to A. That's basically what they mean. Then let me see how much time I have. I have like 7 minutes or so. Then yeah, I'm just gonna go to doubly linked lists, and these look almost the same as singly linked lists, except in this case we have a next pointer and the previous pointer. So previously I mentioned that for singly linked lists you cannot go from B to A, but the good thing about doubly linked lists is that you can. So if you were at, let's say, C, you can move in reverse and arrive at A through the previous pointer. So that's basically what is meant in the first point there, where it says, excuse me, it can be traversed in both directions. That's forward and backwards. So if you wanted to move from left to right, you could use the next pointers. If you wanted to move from right to left, you could use the previous pointer. But bear in mind, whenever you reach a null value, you're at the end of your linked list. Well, in this case, you could be at the end or at the beginning. So that's one way to look at it. And of course, they also contain the data or the values. In this case, we have A, B, and C. And they are useful when bidirectional navigation is required. Uh, you may not see too many questions about doubly linked lists compared to singly ones. So, but it's good to know both of them. Circular linked lists are basically single linked lists, but in this case, our tail points back to the head. And actually, there was a mistake here. The now pointer here should not be there because it points back to the head. So as you take note, this pointer should not be there. The pointer D point or the pointer of D goes back to A. So yeah, and that's usually the only difference. The last node points back to the first node, and that forms a circle because if you look at every point in this list, in this linked list, there is no pointer that points to none because A points to B, B points to C, C points to D, D points to A. And that sort of forms a cycle. So yeah, and the traversal never ends, and it's used for continuous loops. And some common use cases are for like board games and continuous loops in algorithms. So that was just a brief, like an eye opener before you actually start looking at how questions are phrased. But as we go into the breakout rooms, I want you to sort of look at the questions and visualize these linked lists because for linked lists, actually, if you can, get a paper and a pen because it's easier to like work through them as you see them than think of them because yeah, it's just a recommended approach. It's harder to like read them compared to seeing them. So I will create breakout rooms and I am gonna say that's 20, 30 minutes, 35 minutes. It should be 30, it's 40, we should have done it for like 45 minutes, but we may not have enough time to like circle back. Then, yeah, in the breakout rooms, you're going to be solving two problems, reversing a linked list and a linked list cycle. For the linked list cycle, you should already have had a hint from what we've talked about, but you should still be able to solve it. Then yeah, each group will work on this problem using the Ampere method, which we talked about in the beginning. If you were not here last week, that's still fine because um, I'm sure the tutors are gonna be able to help you. So let me create the breakout rooms. So